Good morning, everyone. Welcome back to the Daily Grind. This is a new podcast by Cutting Tool Engineering magazine. We are here back at the Acopian Engineering Center at Lafayette College in Easton, Pennsylvania. Lafayette boasts an unmatched engineering curriculum in all different departments. We have mechanical, we have civil, we have electrical, we have chemical, we have environmental. We even have a new one that recently was accredited, integrative engineering. And that seems to blend all of them into one that's very collaborative and interdisciplinary. And it's very attractive to a lot of the newer students. So if you have a young student or know someone that has a college age kid looking for somewhere to go, I advise you, please apply to Lafayette. Join us and say Colonel, which is why not. So let's make our first cut of the day. I am your host, Robert Lang. Today is a show on preventative maintenance. And our guest, Mr. Chris Tate of Browning Oil Tools, he's running a few minutes behind, so he'll be here very, very shortly. I'm trying to reach him now to get him to sign in. I'm really hoping we haven't missed him. But today's episode is on preventative maintenance and why it's great for your shop. A lot of people feel that it is a wasted endeavor. It is wasted time and wasted money when they could be doing production, which is fine. You have a bottom line to make. I get it. But as a lot of professionals in the trade say, unfinished preventative maintenance is a beast lurking in the shadows. Wear is a problem that affects everybody in the manufacturing industry. So by cutting the corner and not doing the preventative maintenance, you are going to spend boatloads more cash in downtime. Pardon me one second. I have our guest on the phone now. Speaking of the title, The Daily Grind, our title is a double entente to both machining and coffee, being the Daily Grind. Today's is another cup of Black Rifle Coffee Company's Spirit of 76. It's very, very good. I really enjoy their coffee. I've had a couple of their cups on the show. Speaking of coffee, I'm still looking for a connection for a collaboration deal. So if you are a coffee executive or know of one, please have them reach out. I believe Mr. Tate is trying to sign in now. Let's see if he joins us. I do apologize for all this hiccup. I think there was a miscommunication with the time zones. Mr. Tate is an hour behind us here on the East Coast. So another point to make before Mr. Tate joins us is preventative maintenance includes actively being at the machine aside from filling the oil, topping up the grease, or changing out parts. We here at Lafayette have a practice where we will boot up the spindles and fire up the tool changers for all the automated machines. We have two CNC machines, one lathe, one mill. They are out of camera now because I'm looking at them. And so what we do is we run the spindles at various speeds for a certain amount of time to soak the spindles and get them warmed up. We also run all the tool changers to make sure they don't stick or lose a position. So that is one of our generic preventative maintenance procedures. One of them, another one is every week we will go around and even if it doesn't look like it needs it, we'll top up the whey oil, we'll top up the grease and all the bridge ports you see behind me. And the ones in our other smaller machine shop, we will top up the grease in the head every week. It seems like a little overkill. It seems like wasted time. But you loyal listeners and readers or audience will understand my viewpoint and where I'm coming from when I tell you of our practices. We come from here at Lafayette, where our parts don't necessarily make the money. It's the successful engineers that come out of our programs that really make our bread. So we will spend extra time doing things that some shops see as they call them non-value added tasks, like preventative maintenance or uh, anything we can do to prevent downtime. I think Mr. Tate is about to join us. So another thing we do is we have over the years developed a procedure for things that we know will go bad or be worn out by the end of a year. So we have a water jet, which is again just out of view of the camera, and yearly we will swap the oil in the pump. And really, we have, I think, on our machine, we've had our machine for 12 years now, and we have less than 600 hours on it. That is a very lightly used machine. And our CNC mill is 23 years, 24 years old now, and I think it has less than 3,000 hours on it, running hours. Now, a lot of those running hours are idle. A lot of those running hours are firing the spindle up to make sure it's still running good, firing the tool changer to make sure everything is still tip top. And while we do have some long runs or we have some production runs, very, very light production runs, less than 100 pieces each, we spend a lot more time setting a job up than running it, which is indicative of a service shop, I understand. But another thing we do is back to the water jet, because I have a habit of veering off a little bit. Another thing we do with the water jet is in the cutting head itself, the carbide mixing nozzle goes. It wears out after a year's time. We run our jet a little bit rich with garnet flow to make sure that we're cutting our part. So we will swap out, pardon my terrible uh, twisted tongue. We'll swap out the carbide nozzle, the mixing nozzle, once a year. Oh, gosh, if I don't have this coffee, I can't get through my day. I don't know about you guys. Now, we'll also swap out some basic wear parts and we'll top up the oil in that machine. As to things like our CNC lathe, it's a prototyping machine. If you guys are familiar with Southwestern Industries and ProtoTrack, we picked up one of their TRL 1630SX machines in 2014 as well. It's served us very, very, very well. It's very light duty. I can't say it's light duty. It's we use it very light duty. I think that has less than 1,000 running hours on it. It's also 12, 13 years old. Again, that one is also a majority of that is just kicking the spindle on, doing the preventative maintenance on it, make sure it still runs, topping the coolant up, checking the coolant pressure, and all those things to make sure things are still running great. For our manual machines, we have adopted over the years, we've learned after doing it so many times, and we've just adopted it into doctrine, is replacing the belts. So some feel that replacing the belts on a manual lathe or a manual mill, even if you have a belt drive mill, is wasteful. It's just wasted money. It's money that didn't need to be spent if it's running. I get it. I do. You have parts to make. You have money to make. Get it. How much money or how much time in downtime have you lost by a machine going down? And what seems like a simple thing like a belt right in the middle of a part run is catastrophic. To give you an idea, is we had a machine go down in 2024. We had one of our knee mills throw the timing belt in the head. I'm sorry, the V belt, the drive belt. And there was an awful racket up top. So we decided to over the summer, when we are least busy, to take it down and do a complete rebuild. Bearings, belts, grease, bushings, everything. And it took, since it was the first time I've ever done it, it took a couple of weeks. But um, it took us a couple of weeks, myself and one of my coworkers, doing this, and uh, we learned along the way of what to look for. Since we had the entire machine apart, down to the spindle bearings, we had it apart, and the drawbar. We learned what goes on in the machine, what to look for, what to listen for, and what to not allow to happen again. And in that same vein, we decided to do the other variable drive knee mill in our shop. So that is the one over my would be my right shoulder, is the one you see that we rebuilt first, and then the one over my left shoulder, which may be obscured by the pylon in the room, is the second one we rebuilt. And that one we did a very similar rebuild. We didn't go into the bushings or into the spindle bearings or that, because those seemed to be okay at the time. But it did show signs of the belt going. We had a lot of dust flying out of the variable speed changing apparatus. And when we saw a lot of dust and what smelled like cooked brakes, we immediately decided to prevent the problem, preventative maintenance, and go in, replace the belt, refill all the grease in the head, which had broken down over however many years old that machine was. I can guarantee with decent certainty that we are the first people to change out those belts and that grease in that head. And I believe we dated these machines to the 70s. So that's 50 years that machine served before it was deemed to be necessary to replace the parts. We have since learned to, again, prevent that problem by going in and checking the belts, taking the time to take the covers off, inspect, and make sure that this doesn't happen again. Now, there are unseen things that you're going to come across, like if a machine just pops a coolant line, or let's say that it pops an oil line. An oil line is the worst. We had an oil line go in the x-axis of our CNC mill. I'm very thankful that it was a simpler fix than I had originally anticipated. We have a Haas VF2 from 2002. So again, we got 20 some years of reliable service out of that machine before the oil line decided to dry rot and pop. And nothing is scarier than the control throwing a red flag and saying, "Uh-oh, no oil, can't run." And if this had been industry, doing the grind and making the money and making the parts, this should have been a problem. It would have been fixed quickly and been on our way. But that would have probably been by qualified service techs. That's not to say we're not qualified. I think the more appropriate term is certified service techs. And since this is another first time we're doing this, it took considerable amount of time to find the problem, diagnose it, fix it, and then button the machine back up. I think we lost a week to that. But thankfully, and I thank my lucky stars every day for this job, I pinch myself realizing just how good I have it here. That we can afford the time to break the machine down, fix it, and get it back in action. We had a problem with our CNC lathe once, that the timing belt for our tool changer. So this machine runs on a timing belt for the 8-position tool changer, and it just happened to skip teeth and rip teeth off of the belt. So now, yearly, when we drain the head of its hydraulic oil and put new oil in, we inspect the belts, the drive belts, which at this point being, what is it now, almost 12 years old that we've had this machine, we might be replacing belts this year just to prevent one from snapping and causing a problem. While we have the machine open, it is an extra step, minimal added time, minimal added cost up front to prevent massive cost on the back end. And that is the example I've always used whenever I speak to anybody about preventative maintenance. Back to the manual lathes. We have a manual lathe in our other shop that is probably also 50 some years old. And we've replaced the belts on that before at a certain interval, but we had determined back then, because of how little we used the machine, we could probably get away with a longer interval between changing them. We also are of the mindset now, well, not also, we changed our mindset now to pardon me, to do the preventative maintenance of purchasing the belts now, get the parts in, get them swapped while we have the machine open, and prevent a problem way down the road. Our guest today, who will be joining us very shortly, he's on his way to his computer now. We had a little bit of a mishap with time zones. Like I said, Mr. Tate is an hour behind us on the East Coast, and we were under the understanding it would be 8 o'clock my time. Well, I was. I think he believed it was 8 o'clock his time, and planned for that. And being an hour behind, he is. We had a slight miscommunication, so he's on his way. He'll be joining us very shortly. And if you guys see, I have opened the chat. So if there's anything you specifically want to know or ask myself or the guest, please, now's the time to add or reach out via the chat. More basic preventative maintenance things is cleanliness. So again, I'm going to speak on the viewpoint of, when we get done with a job, we take the time, we sweep the chips up, we scoop them out of the machine, we wipe down whatever we use, so the next person that walks up to the machine has a nice clean machine to use, and it's also safer. Here at Lafayette, we have a principle of not one person being assigned to one machine. We all have our strengths and we all have our weaknesses, but we all have access to every machine. So if somebody can't get to that machine to do that job, another one of us can hop in. And as a side note, complete side note, is I wrote about that in a letter to the editor, to Dennis and crew at Cutting Tool Engineering Magazine, about cross-training and how some shops are very hesitant to invest the time and money necessary, be it wages and lost production time, however minimal, to implement a cross-training program. And here at the school, we have excelled. I personally feel and professionally feel that we have excelled as a group of machinists here by taking the time and doing all the cross-training. If you think about it, and if you reference my letter to the editor at any time in the future, you will notice that I had spoken about when I was brought on, I was a little weak in certain types of welding. I could MIG weld like anybody. That really is just point and click. TIG welding took me a little time. I minored in welding in college, but I really got by pretty well there, because I was doing it every night. But with the lapse of time being at the apron because of my first job and not having the equipment in my own personal shop at home, I got a little sloppy with TIG welding. So the guy that trained me here before he retired took the time and sat with me and taught me cross-training. But again, this is another diatribe for another day. Preventative maintenance is what we're here for today, and I could go on and on about all things shop. But another point that I'll bring up is, well, like I said, cleanliness. So before I went on my tangent again, I had spoken of after we complete a job, we'll take the time, we'll drain the coolant, we will sweep up the chips, scoop them out of the machine, wipe the machine down, and get it ready for the next guy. While a clean machine may still be broken or still can break, we feel that it's a necessary step to prevent, like there's a lot of electronics, so you don't want them dirty. And there's a lot of surfaces that you don't want to let get rusty or damaged. So cleaning is a form of preventative maintenance, we feel. We should have our guest here just about any minute. So as soon as he joins us, we will get him on. If anybody in the audience has points to make about preventative maintenance, whether or not they do it, whether or not things should be done, or suggestions, please add them to the chat. Now, a point that I'm going to speak with Mr. Tate about is a point I made earlier in the show today about, and this is an age-old point used by engineers and manufacturers, or anybody really. If it's not broke, don't fix it. And yes, there are places for that theory. There are absolutely places for that theory. If there is a process in place that works, but you don't know the way to improve it immediately, let sleeping dogs lie. But with rotating machinery, metal cutting machinery, anything, and wood cutting machinery, anything, you induce wear by using the machine. And if you don't take the time to do the preventative maintenance, you're going to end up with a beast lurking in the shadows. Now, we will also speak with Mr. Tate about implementing a routine and what that could mean for your shop, whether that means hiring maintenance mechanics that strictly go around the shop, top the oil up, change parts out, what have you. Or if you are a smaller organization that relies on your staff, your shop staff to do the job, what you can and can't do, or not necessarily what you can't do, what you can or should do to implement a proper preventative maintenance routine. We here at the school, again, I speak mostly from my experience here as I've been here 15 years. What we do is as we learn things or as we get new pieces of equipment, what we will do is start documenting what was changed, when, what was done, when. And we keep it in a manual with the owner's manual for the machines in a separate room so they don't get flooded with oil or coolant or chips, dirt, what have you. This way, we can keep a pretty good log of what we're doing to prevent breakdowns or what we're doing to stop downtime and what we've done to fix a machine that did go down. Now, we were donated this water jet back in 2014. And for any of you out there that have or have used a water jet, you know that they can be extremely temperamental. The water needs to be uber pure going into the pump and through the lines, through the head. The garnet has to have a certain flow, air pressure. It has to have certain pressure coming to the pump and from the pump. Otherwise, it shuts down, it throws faults. And when we had the machine installed, as with all new pieces of plumbing or all installations, little tiny fines get from threading the ends of the pipes or the tubes. Little fines got in the system and plugged things up. We also ran into other little things that we immediately documented to know that, oh, this could happen. Let's not let it happen. We also implemented I don't know if it's preventative maintenance or if it's a fix for a process that was giving us trouble. With our water jet, we dumped 55-pound bags of garnet into the hopper that feeds the head. And when you rip the paper bag, sometimes little fine pieces of paper get into the system, into the garnet system. And we had a lot of trouble with pieces of paper and the additional plastic plugging the line. It would get into a corner and stop the garnet flow. It would get into the cutting head and plug up the nozzle. And thankfully, there are systems in place on the machine to prevent massive catastrophic failures by just shutting down. But finding those were just nightmarish. So the preventative measure that we used to stop that was we came up with a little fine mesh gate that we dump the garnet through that catches oversized bits or pieces of paper and plastic so they don't get into the system. And this it was a stoppage of the machine for maybe 2 hours, and I realized that 2 hours is a lot of money. But it was a stoppage for 2 hours to prevent days and weeks of downtime. So a small cost up front to prevent a massive catastrophic cost later. Also, we have implemented other things. Filters. Filters are another one. So what have you done specifically? Or what have you been able to do or implement? Or what would you suggest is implemented for shops to keep things going? I would love to know your feedback. Please reach out. Our guest is signing on here any minute. We will pick up with him in just a moment. I think. Let me see. Where is he now? Okay, so he is still about 10 to 15 minutes out. So you guys get to listen to me for that much longer. Hooray! As for other things, now, as for shops that do not just metalworking, we have a small but rather capable wood shop built onto the side of our building, and that has its own potential problems. Now, they're machines just like any other machines. They're belt driven table saw or radial saw, chop saws. We have a lot of um, very, very good woodworking equipment. But when those machines go, they also go catastrophically. So the preventative maintenance we do in there is again swapping a belt on the motor. Let's just say for ease, it's a $50 belt. While that seems kind of a little expensive for a piece of rubber, it's $50 now instead of hundreds or thousands of dollars later. Blades, we go through blades rather. As of late, we've been going through blades crazy. We have a new professor here in the civil department that has built all of his tenure research equipment out of 2x4s and foam. And you wouldn't think that foam would beat a blade up, but my goodness, we have replaced 10-inch saw blades. I think we used to do it once a year just out of practice, but we've gone through quite a few now just to prevent problems. We'll be replacing it again here in just a few days. But belts, all of our machines here are driven, except mind you, except for the VF2 Haas and not even the water jet. The water jet pump runs on belts. But if you don't have the capital to hire out factory technicians, learning to do a preventative maintenance routine in your shop will save you boatloads of cash and boatloads of time, even though you might lose one of your machinists up front or one of your staff up front for a little bit. The point being is you have to spend a little money to make a lot of money. And if you wish to prevent downtime and lost cash, you should really look into maintaining, or no pun intended, maintaining a preventative maintenance routine. So with that, we are going to take just a short break, and we will be rejoining with Mr. Tate from Browning Oil Tools. I believe he's just about to sign on here in just a few minutes. So with that, let's have a cup of coffee or a drink of coffee, and we will be back in just a moment. Now, while we are waiting for Mr. Tate, let's see if we can think of any other preventative maintenance things that would benefit your shop. You know what? Airlines. So just about every shop, I think every shop has to have an air compressor, airlines, compressed air at the machines, whether it powers part of your machine or if it's just for the air hoses to clean off your parts. And that's a whole other topic for another day that we can talk about if you use the compressed air to clean off your machine or not. And I am of the not camp uh, because it compacts chips up into the ways and the gibs. And if you have a glass scale encoder on the back of your machine, it's just waiting for problems to happen. So I'm of the minimal use of the compressed air and mostly brush and rags. Um, but that might date me. I don't know. That's just my personal view on it. But airlines. So airlines seem to be one of those things that it's buy it once and it lasts forever. But most of you know, in a shop you have sharp metal chips. And if sharp metal chip gets on that line and somebody grabs it or glances it and cuts it, then you got to replace it. So Another thing you can do is go around and just check all your airlines and all your connections. And these, again, these seem like minimal, tiny things. But how much time have you lost trying to source another airline and quick connect fittings, shutting the air off, draining the line, popping the old line off, putting a new one on? Whereas if you have those things pre-assembled, it's just a matter of draining the pressure, swapping the line, and going back to work. I feel that's a preventative maintenance thing. Back to our CNC lathe, we have compressed air that feeds the, I want to say, solenoid switches that tell the machine to change tools, or there is a compressed air line for cleaning off parts. And our tool changer runs on compressed air. So checking those lines to make sure they're not leaking, replacing them once a year or once every so often is a very good idea. The electronics on your machine. So our ProtoTrack lathe uses a Windows embedded type control. It's conversational. It's a very user friendly machine. Hence why any one of us can walk right up to it and use it. But the electronics, we run diagnostics on the computer. We have a coworker that was very good to us in that he imaged the computer. So if we were to have a problem, we could immediately shut it down, re-image the computer, and be back in action in almost no time. Instead of waiting for, so this is called the pendant. On these machines, they call them the pendant. Instead of waiting for ProtoTrack to come out with a new pendant, install it, connect it, and just make sure it's running right, we have a fix on hand. And these are all things that you can develop in your shop. Another one's bandsaws. So I forget what month it is. I said it in my last episode, the month of sawing. We'll be going over all things sawing. But the preventative maintenance of blades. The one thing that we have adopted is making spare blades. When we find ourselves with a little bit of downtime, one thing that all four of us practice is the fabrication of spare blades. We have on the inside of the machine, we have of each one. So they're all different lengths and they're all different tooth pitches. We have the length of the blade used for that machine written inside. And we have Starrett sells saw stock, I guess you'd call it, just bandsaw blade material. And we can cut it off to length. And we have a welder built into one of the machines that does the job of welding the blade together for us. So if a blade goes down, we pop it off, put a new one on, and we're back in action instead of waiting for the time and the pressure of cutting a new blade, making sure the weld's good, making sure it's annealed properly and ground off so it doesn't crash in the guides. So there's another one. The machine itself, we grease the bearings. We make sure that everything is up to snuff and still cutting true and straight. We tighten the guides. We tighten the tensioning wheels to make sure that the blade doesn't wave on us or cut errantly. Oh, we have a horizontal powered bandsaw. So that one's another beast in that it has flood coolant, it has pneumatic lines, it has the electric power that is needed to run it. So we make it a thing. The preventative maintenance on that one, going back to the cleaning, the preventative maintenance on that machine is after we get so often, if we have a huge order of parts, and I say huge, if it's over 20 parts, it's massive. So don't hate me. If we have over 20 people or pieces, it's considered a massive order here at the school. And sometimes they're big pieces. Sometimes they're of a material that makes a lot of chips. I'm talking about aluminum. Aluminum on that saw seems to pile them up. And so after the coolant drains, we'll scoop out all the chips so it doesn't allow chips into the coolant line, into the coolant pump, and causing damage there. We also make it a habit to run. We take the feed line off of the coolant to the blade. We just run that dry and fill it back up with fresh coolant once a year or every so often. That machine seems to burn off coolant with the interface of the cut quite often. We see a lot of steam off that machine. So we will make it a habit to keep the coolant topped up. We check the guide wheels. We check the tension on the guide wheels. We have certain settings notched on the wheel. So when we get to a certain point, after the blade's been used a bit and it stretches, we go to the next notch. Or if it gets to a point where it's too far, we just replace the blade. We have also gotten into the habit of once a year replacing that blade, whether it be necessary or not. And it seems kind of wasteful. If we have a blade that's still in use, we'll probably get as much use as we can out of it. But if we have, to give you an example, I believe it was 2015 into 2016, or it might have been the summer of 2015, was Lafayette Engineering's 150th anniversary. So 150 years of engineering here at the school. And we had I forget, I think it was a 1/4 scale bridge made of timber and steel connections made here. We bought all the lumber, we bought all the steel, and that saw ran for 2 weeks straight. We were just piling the coolant and the chips up. So what we'll do is we'll take the machine after we have a job like that, we'll block it out and we will completely strip it down. We'll take the blade out, we'll scrape all of the schmutz out of the two guide wheels at each end. We'll check the brushes and we'll clear the brushes off. We inspect all of the pneumatic lines. It's actually hydraulic. Forgive me. There is pneumatics, but there's a hydraulic system that actuates the clamp and moves the head up and down for us. I forgot all about that. And one time we had a hydraulic line pop out of age and spilled hydraulic oil all over the place. And that was a mess in its own. But now we make it a thing every year. We will, after every so often, we will clean all the chips out of the machine, wipe it down real well. Again, wiping it down. I know that seems wasteful and time wasting. I get it. But it is also necessary, we feel. And we'll go through and inspect all the hydraulic lines. If we have to, we'll drain the pressure and replace a line and bleed it, just much like you bleed brakes on a car. And we will inspect all the pneumatic lines. If we have to replace one of those, again, drain the pressure, replace a line, and we're back in action in hours instead of days. So that is, all of these things I've listed are, again, our viewpoint and merely just what we see here. But it is, I believe, a very, very, very good process to implement into your shop if you wish to stay competitive and stay productive. So let's see, is Mr. Tate able to join us? All right. Mr. Tate should be joining us any moment. Let's see, are there other machines that we use? Here's a simple one. Our arbor press. So that's just really just a rack and a pinion on a stick. It sounds simple, but there are pressure plates that keep the rack aligned and allow it to move in a straightforward manner. We will take the entire machine apart and replace and grease those pressure plates to keep things running true and to be able to properly apply pressure to parts. If you were to have that rack come undone or separate from the pinion, it could be a catastrophic problem. And so again, preventative maintenance. We have a hydraulic ram over my left shoulder in the back of the shop that we have replaced the seals on. So that's another one. Seal replacement is another very good point about preventative maintenance. If you have something that runs on oil or water cooled or sealed seals, make sure that you're operating that machine or you're keeping those seals wet and working to prevent one of those from cracking and failing. Another one is, and I'm sure everybody on the planet has hopped on this bandwagon, 3D printing. So if you do some 3D printing that requires, they call it support material, excess material printed to support an overhanging part, you need to be able to eliminate that support material. And one of the machines we have uses a water soluble support material. So you can essentially toss it into a vibrating bath with just tap water, and it dissolves the support material while leaving your part completely ready to go. But being a college, as you can imagine, the summers and the winters are our dead period, and or I can't say dead period, are more quiet periods. So while we are busy 24/7, I can't say 24/7. I can say 5 days a week, 50 weeks a year. We're never not busy. We are always, always, always into something. Being the engineering shop for a an engineering department or division, a very good one, by the way. We have machines that get to a point of almost being idle for months at a time. And we learned the hard way one time. We let our 3D printer bath sit for, I think, 6 months of not being used. And it's one of those out of sight, out of mind things. And after having to take that entire machine apart, down to the pump, separating the impeller from the motor, and replacing every seal in the line, replacing all the lines that dry rotted, and all the seals that dry rotted, and the magnetic drive impeller, all of those things, and reseating them. That was a very costly mistake. And it's easy for me to say these things as I'm not the one writing the checks. I can spend somebody else's money all day long. But we learned very quickly to, even if there's no part to be run, and even after I get off the show today, I think I'll just go over and do that. So as I remember it, this is Mr. Tate now, getting online. So we will be joined by Mr. Tate in just a minute. But to finish that thought, I think after I get off the show today, I will just go run the parts bath to make sure all the seals stay wet and we don't have another complete rebuild to do sometime in the summer. So let's see. He is trying to sign on now. Let's see if Mr. Tate is joining us. Let's see. Oh, we're having a little bit of a technical difficulty. Let's see if he signs on in just a moment here. So to give you a little pre-show introduction, Mr. Tate, Chris Tate, works for Browning Oil Tools as the general manager, and he has written a treatise on. Oh, Chris, is that you?
That's me.
One second. I think we have the. Try again.
Hello?
Oh, boy, we're having another volume problem. Let's see. Oh, wait. Come on. You there, Chris?
Yeah, I'm here.
It's still not here. Darn it. We are having a little technical difficulty. Oh, shoot. Add the scene. Try something.
Yeah, everything seems to be working on my side.
Still not hearing you. This is a. We've had this problem before. Let's see if we can fix it. Here, let's close this. Let's see. Speaker. Let's try that. Chris?
Yep.
Hey, there you are. All right. Forgive the little problem. We had a little technical difficulty. How are you today?
Good. How about you?
Fantastic. Living the dream. It's Monday, but.
Yeah.
So I do apologize about the time zone error, but thank you for joining the show.
Yeah, I don't know. I had it on my calendar at 8. I don't know what happened. I apologize.
That happens. This is the biggest problem we have all week. I think we're going to be just fine. So I wanted to say Cutting Tool Engineering, and I can't thank you enough for taking the time to sit down with us today. So I gave a small little inkling of who you are to the audience, but if you could please share a brief backstory, highlighting any big experience you've had and anything you'd like to specifically point out. Please include a shameless plug for your employer.
Um, well, so I've been in machining, fabrication, welding for about 33 years now. I started off running the family shop, and we had several iterations of it. It was in Tennessee and Mississippi, Kentucky at one time. Anyway, did that for a while. Um, Left, went out, started working for, um, well, I actually went into the automotive industry for a few years, then into aerospace, all as a manufacturing engineer. Um, Eventually ended up at Mitsubishi Power Systems, building land-based gas turbines.
Yep.
That was probably the most interesting um, of my early career experiences, and stayed with them about 12 years. Did everything from manufacturing engineering to you know running, managing several of the uh, shops inside of the manufacturing facility, um, but always around machining, welding, and fabrication. So the last job I had there was the heavy machine shop. We had, of course, the land-based gas turbines are enormous. They're 500,000 pound jet engines, essentially.
Good.
That's what used for power generation. So when they talk about making electricity with natural gas, they're running it in a gas turbine. And three big players are Siemens, Mitsubishi, and GE. Anyway, heavy machine shop. We were machining forgings that were, 2 meters in diameter and meter and a half, 2 meters tall. Weighed anywhere from 5,000 to 40,000 pounds,
Ooh.
and so did that for a while. Um, Ended up running a repair shop in Texas after that, where we repaired steam turbines and gas turbines. And then wife and I finally decided that it was time to move back home to Mississippi, and uh, came back and did a few contract jobs with some people that I knew from the power generation industry, and eventually ended up uh, met a brother and a sister who own a company called Browning Oil Tools,
Yep.
and their father was the founder, and um, through some uh, anyway, they ended up buying out the other partners and owning the business outright. Neither one of them are familiar with manufacturing. They were looking for somebody to come run it for them, and through a stroke of luck, we got connected. And so I'm the general manager at Browning Oil Tools now, and we're essentially a big machine shop. We have 25 pieces of equipment, various complexities, and we make a thing called an on-off tool, which is essentially a quick change device for um, downhole reciprocating pumps. So much like a quick change device uh, in the machine shop, where you set something up so you can change over quickly,
Yep.
or change a tool quickly, or whatever that might be. This does the same thing for the guys in the oil field. The founder patented this device several decades ago, and it's the mainstay for us. So we manufacture those, and along with other pump components that you would find downhole, and sell them. Texas, North Dakota, California, Canada. Even overseas in some cases. So um, fairly small shop. Got 19 people, um, and just so it's a fairly straightforward. Most of it's turning work. Only do a little bit of milling, and so anyway, I've been here coming up on a year now.
Wow. So to go back to your time at Mitsubishi, uh, and this is a very vague link, but back a while ago, you had actually written an article for the magazine about preventative maintenance, and this is the meat and potatoes of today's
Yes,
show.
yes,
So I don't remember exactly what issue that was, but I do believe you had still worked for Mitsubishi at the
I
time.
did. Mhm.
Now, did you, because of writing that, or as a kind of a segue of you writing that, were you in charge of PM there?
Indirectly. So we had a maintenance department that oversaw maintenance and repair of all of the equipment in the facility. But as a operations manager, obviously it was in my best interest to make sure that the equipment that was in my shop was properly maintained to, so that we could stay in production mode and not suffer the from downtime and things that go wrong when you don't maintain your equipment. So while I did not have, direct responsibility for the guys that were doing the work, I was very, very close with the maintenance department, and my engineers did a lot of work with them to keep the equipment in proper working order.
Very good. So I had it right here. One of my coworkers, it comes from a big time manufacturer of forgings, Atlantic
Mhm.
Forgings up in Phillipsburg, New Jersey. And they had a routine that we actually follow here as well. I was speaking about it before you joined us. Is the first thing we do? Oh, it's not right now because I'm in the shop, but and recording. One of the first things we do on every Monday morning is we walk around and we top up all the way oil. We pump grease into the heads of our Bridgeports, and we fire up the spindles and tool changers of our CNC machinery just to prevent sticking and prevent loss of timing.
Mhm.
And we find that if we don't do that, we have a lot of sticky spindles and sticky tool changers
Mhm.
and uneven wear. And would you also consider using or putting tooling in different spots on your machine at different times of form of preventative maintenance to prevent uneven wear?
I think the answer to that question would depend on the environment that you're working in. So if you think about in the automotive industry, for example, um, when you go onto a machining line, it's very rare that you find a machine that only has one or two tools in it, right? So if it's got a yeah, a 50 or 100 or 200 or however many it might be station tool changer or tool magazine, they're using all of those tools. They're coming in and out, coming in and out, and there's a pretty routine flow.
Okay.
Uh, Now, if you go to find a shop where maybe they have a small vertical machining center, and they're running the same part every day, and they're drilling two holes and tapping two holes, and maybe milling a slot or something, and they've got 4 or 5 tools in a 25 station tool changer. Then yeah, I could see how rotating those through would be beneficial to um, getting even wear across all of the components.
Okay.
Those are so the big thing with maintenance. You were talking about going around and checking the fluids and operating the tool changer and
Yep.
warming up the spindles and things. So in especially in automotive settings where people are practicing Toyota production system or lean manufacturing, or pick any one of
Yep.
the
I've
names. Um, they have what they call OPM, which is operator performed maintenance,
Okay.
and that is typically when it's done well, there's a checklist, and the operator at whatever the specified interval is, usually daily, or by the shift, right? So if you're running a 3 shift operation, when you come in and to your shift, whether it be in the morning, the evening, or whatever, you perform the checklist or go through the checklist. And those can be fairly simple. It might just be, checking some fluids. You might read an air gauge, you might read a hydraulic gauge, but when it's performed well, they collect data while they're doing that. So on that checklist, they might go back to the hydraulic system and read the pressure, make sure that it's set at whatever the appropriate pressure is, or reading the pneumatic system to understand that it's sitting at the appropriate settings. There might be, they might read some type of electrical device that's monitoring the amperage coming in or voltage in a particular system or whatever, and then they take that data and they put it back into some type of spreadsheet or software package, and it allows them to monitor the performance of the machine tool over time. And that's a very big part of maintenance is having that. If you're doing it well, then you've got an OPM system, operator perform maintenance, that focuses on the critical elements of the machine, things that are from a skills standpoint appropriate for a machinist or operator to be monitoring, and then you're taking that data and using it to predict overall performance of the machine.
Sort of to predict when you may have a breakdown or when it's time to switch something out.
Exactly.
Very good.
So when, like I said, when a organization, when a company is they're really good at maintenance, then they're looking ahead and using that OPM as a data gathering tool.
So before you had joined us, I was going through what we do here at the school for preventative maintenance, where we actually will log. We don't have a lot of Industry 4.0 yet, but we will manually log whenever we change belts, if we change a bearing out, whatever, the littlest thing. So we know we have a documented system of what happens when. Now, another question I have, I know we are running a little low on time, but I'll ask you these last couple of questions. If someone were to be hired in your shop tomorrow as, say, a maintenance leader or leader of the maintenance crew, what tips or advice would you give them on frequency of routines, and what would you suggest they spend their time focusing on?
So I'm gonna use Mitsubishi as an example more so than Browning. So here we're a small shop, and we're in the process of modernizing a lot of things, maintenance being one of them. So my maintenance program here is not what it should be yet. But at Mitsubishi, for example, if we were to go out and hire a new maintenance manager, let's say, or maintenance supervisor, maybe, and the advice there would be, again, to however you do it is start collecting the data, understanding, to your point, what is being serviced, what is being repaired, when, in terms of hours. That is, of course, you're familiar with TPM, total productive maintenance.
Yes.
Which is, again, when it's done right, you're looking at the time on the machine. You understand when components fail based on that time. And places like Toyota, for example, they know that they get 5,000 hours, let's say, out of a spindle on a horizontal machining center. And they know at 5,000 hours that they're going to pull that spindle, whether it's bad or not, and put another one in. Same thing with things like proximity switches, right? So you got a lot of proc switches on a machine tool that give feedback to the control, allowing the machine to know where it is and perform the logic functions inside the PLC. Well, those things, when you lose one, the machine doesn't work right.
Yes.
So, they plan these things based on the known life of the components. Of course, Toyota has mountains of data on all of these things, and they are able to, better than most places, predict these failures. So for a new person, having them understand what TPM is, having them research it, maybe even, trying to go on a tour somewhere if you can find a place that does it well, and gain experience from their maintenance staff, would be very, very important for somebody that is new and somebody that you are expecting to actually maintain the machines rather than repair. That's the other big thing is, we say maintenance, but most places aren't really performing maintenance. They're repairing stuff. It breaks, they go fix. Uh,
Yes.
if you're maintaining the machines, then, and again, doing it in a world class fashion, then you're predicting the failures and acting on them according to a plan. And again, from if you're planning your maintenance, then you're also doing it from a financial standpoint, and that at given intervals you're going to come out of production with a piece of equipment, and it's going to be out of production for a given time because you know what you're going to do to it, you know how long it takes to get that done. And so now, from a financial standpoint, you can plan that and understand what the impact is rather than dealing with unpredicted downtime, where the machine breaks and now you've got to order a part, you got to wait for it to get there, you got to get it installed, you got to test the machine, you got to go through all this stuff. And that impact is much greater because you weren't planning for it.
Yes.
So
We had a welder go down that, I mean, it was a relay, so it wasn't something that you would normally necessarily go checking all the time. It's a hidden inside the machine relay, but it turned out to be a timely and or time consuming and costly repair.
yeah,
But now, our last question for the day for the viewers is: this is a statement I heard a while back, and I completely disagree with it. And I want to know exactly how you feel about it. Is somebody said preventative maintenance that prevents nothing is a what is it? A wasted endeavor. And I disagree completely, just by the points that you've made as well. Is you Toyota being your example, and Mitsubishi, that you knew how long you got out of a machine, and then you took it down and did the repair or the maintenance.
you did right.
Whereas instead of just putting it off, putting it off, putting it off. So I realize you went into in pretty good detail with Toyota and Mitsubishi, but do you also disagree with that statement?
Well, if you think about the wording, preventative maintenance means that you are working to prevent failures as opposed to repairing, like we were talking about just a moment ago.
Yep.
So the goal is to know when that machine is coming out of service and it be part of your financial plan and part of your production plan. Um, and that way you can set, financial goals around it. You can set production plans around it, and you you're not being surprised by failures. That's the whole reason for performing preventative maintenance. So if that is not valuable to the company, then a preventative maintenance program does them no good. So it gets to values, right? Some places are okay with, hey, it's broken, we'll just go fix it, rather than I don't want it to go down in an unplanned fashion and then I have to deal with the fallout from it. So I guess it really depends on the culture and the leadership at the particular organization. It's interesting. You'll hear a lot of executive leadership promoting TPM, and it's almost that they're jumping on the bandwagon because it sounds good and that's what you should do. But in the end, a lot of times they don't support it financially, meaning they don't allow the budget to be set up to, say, change a spindle that has not failed yet, or to change electric components or whatever it might be. So when you prepare a budget with the thought of performing preventative maintenance, and you put at Mitsubishi $1 million in it, and then they come back and they go, no, we're not budgeting $1 million for that. The machine's not even broken yet. Well, don't you want to have a preventative maintenance program? Don't you want to practice TPM? That means we have to have we have to have inventory. We have to have a budget for the labor. We have to have a budget for things that may not be in the inventory. And now we're planning that $1 million rather than, they'll flip moments where you have a failure and now you're trying to find that $50,000 for, a new servo, or because on those big machines at Mitsubishi, the servos were the size of a desk. But you
Yeah.
know, and now all of a sudden you have unplanned downtime. You're not meeting your production schedule, and you're torching your budget because you didn't have anything in there for the surprises. Um, so I think the answer to your question is directly, yeah, I disagree with that statement. The whole idea is that you do the maintenance so that you never get surprised. But there are lots and lots of companies out there who talk a good game, but don't practice it in the end.
Well, that's a good point. Oh. Uh, Chris, I can't thank you enough for taking the time to sit down with us today. This has been very helpful, and we are looking forward to airing this and hopefully helping some people implement or tune up their preventative maintenance routines. This has been Chris Tate with Browning Oil Tools. Again, Chris, thank you from all of us at Cutting Tool Engineering and here at Lafayette for taking the time to speak with us today.
Been great. I appreciate it. Thank you.
Take care.
All right. Have a good day.
You too. Bye-bye.
Bye.
To all our listeners and viewers, this has been the Daily Grind, episode 6, titled Preventative Maintenance is No Issue. I want to thank you very much for listening. Make sure you tune in next week, same time, same place. Have a great rest